Okay, good day, my dear reviewers. So today we'll be having our review class in mechanics, and I will be your review master, like Lawrence MLArcena, and welcome for today's review. Here are the coverage for today's review. First, we will describe and differentiate scalars from vectors, and we will classify different physical quantities such as speed, velocity, distance, displacement, and acceleration as scalars or vectors. Second, we will describe and differentiate speed from velocity. Third, we will also describe and differentiate distance from displacement. And lastly, we will describe acceleration. Also, we will be solving problems related to speed, velocity, distance, displacement, and acceleration. To start our review, we must know first what is mechanics. Mechanics is the branch of physics that deals with the action of forces on bodies and with motion comprised of kinetics, statics, and kinematics. Kinematics. So what is kinematics? Kinematics is the science of describing the motion of objects using words, diagrams, numbers, graphs, and equations. The goal of any study of kinematics is to develop sophisticated mental models that serve to describe and ultimately explain the motion of real-world objects. So the main goal of kinematics is to describe the motion of real-world objects. Since kinematics has something to do with the description of motion of real-world objects, so how will you describe the motion of an object? In describing the motion of an object, here are some words or phrases that are often used in describing these motions of certain objects, just like going fast, stop, slowing down, speeding up, or turning. So let's just say, for example, the car is going fast, the car has stopped, the car is slowing down, the car is speeding up, the car is turning. So these are some examples of the words or phrases that are commonly used in describing the motion of an object. But these words or phrases does not completely describe the motion of an object. So we must consider the different physical quantities to completely describe the motion of an object. So what are these physical quantities? Here are the different physical quantities: distance, displacement, speed, velocity, and acceleration. Before we proceed in describing these physical quantities, we must first describe and differentiate scalars from vectors. Scalars are quantities that are fully described by a magnitude or numerical value alone, while vectors are quantities that are fully described by both a magnitude and a direction. Remember, scalars focuses only on the magnitude alone, while vectors focuses in both magnitude and direction in relation to the movement or motion of an object. For us to really understand the major difference between scalars and vectors, we must consider or take a look at this table. So the first column, we have the different quantities. On the second column, we have the different categories such as scalars or vectors. And in the example, the first example, we have 5 meters. And each category is a scalar or scalar quantity. Why? Because scalar is more focused on the magnitude alone or the numerical value. So 5 meters is a numerical value. So we can say that it is a scalar quantity. Numerical value has a number and a unit after this number. So without this unit, um, we are not we cannot categorize this one as scalar or vector because it will not describe the motion of an object. So it must have a unit which is a meter. So 5 meters is a scalar quantity. How about the second one? 30 meters per second east is a vector quantity because vector quantity is focused both magnitude and direction. So the magnitude or numerical value is 30 meters per second, having this unit meters per second and a direction which is the east. So it is a vector quantity. The third one, we have 15 meters per second. Its category is scalar because it has a number and it has a unit. It is a numerical value, so it is a scalar quantity. So how about the last one, the negative 14 meters per second? It is a vector quantity na kung papansinin natin wala namang direction, di ba? So why is it that it is a vector quantity? Because the direction is indicated by this negative sign. So this negative sign indicates the direction of the movement of the object, if it is leftward or downward. Basta in the negative direction. So this negative sign indicates the direction. So meron tayong numerical value which is 14 meters per second squared and a negative sign that indicates the direction. So we can say that this is a vector quantity. Now we'll be describing and differentiating the different physical quantities, starting with distance and displacement. So what is distance? What is displacement? Distance and displacement are two different concepts. Distance is a scalar quantity that refers to how much ground an object has covered during its motion, while displacement is a vector quantity that refers to how far out of place an object is. It is the object's overall change in position. So the main difference between distance and displacement is that distance is a scalar quantity. It is more focused on the magnitude of the travel of an object. It refers to how much ground an object has covered despite of the direction of travel, because distance is a scalar quantity. It is independent of the direction of the motion of an object, while displacement, being a vector quantity, is more focused on both the magnitude and the direction of travel. Also, displacement is the object's overall change in position. So meaning, if an object doesn't change its position during its travel, meaning there will be no displacement. So the latter part, we will be solving different problems, different cases related to distance and displacement for us to really differentiate distance from displacement. For us to really understand distance and displacement, let's consider this problem. A physics teacher walks 4 meters east, 2 meters south, 4 meters west, and finally 2 meters north. And we are to find for distance and displacement. So here's the figure of the travel. So we can see the physics teacher walks 4 meters east, 2 meters south, 4 meters west, and finally 2 meters north. So this will be the figure of the travel. So what will be our distance? We all know that distance refers to how much ground the object has covered. And also, distance is a scalar quantity. It is more focused on the magnitude of the motion. It doesn't care about the direction of travel. So meaning, we will just add these numerical values, 4 meters, 2 meters, 4 meters, and 2 meters to come up with the value for distance. So the value for distance is 12 meters. The value for displacement naman is 0 meters. Why? We all know that the displacement is a vector quantity. It is more focused on both the magnitude and direction of the travel. But then, displacement also talks about the object's overall change in position. So at this point, at first, the physics teacher is at this point, its initial position, in which it travels 4 meters east, 2 meters south, 4 meters west, and finally 2 meters north. So meaning its final position is the same with its initial position. So there will be no change in position at all. So meaning there will be no displacement, because displacement is the object's overall change in position. But since the initial position is the same with the final position, there will be no change in position, so displacement is equal to 0 meters. Let's try the second problem. An object moves from point A to point B as shown in the diagram below. Find the distance covered by the object and find the magnitude and direction of the displacement of the object. So here's the figure or the diagram. So as we can see here, the object travels from point A to point B as shown in the diagram. So the initial position is 0 and the final position is 11. So we are to find for the distance covered by this object and the magnitude and direction of the displacement of the object from point A to point B. So here's the solution for the second problem. So the distance taken from point A to point B is 11 meters since D is equal to point AB. So distance being a scalar quantity doesn't care about the direction of the travel. So it is more focused on the magnitude of the motion. So from point A to point B, we will just add the numerical values. So from point A, 0 and point B is 11. So the travel or the distance covered by the object is 11 meters. So how about displacement? The magnitude of the displacement of the object is also 11 meters. Since the formula for displacement is change in x is equal to xf minus xi. We can solve for displacement. So meaning, the symbol for displacement is this delta x or change in x, in which change in x is equal to final position minus initial position. So xf is the final position and xi is the initial position. So we can solve for displacement with the given xf is equal to 11 meters, which is the final position, xi is 0 meters, which is the initial position. So what is change in x or the displacement? So the displacement is equal to 11 meters minus 0 meters. So displacement is equal to 11 meters to the right or east, because the direction of the travel is to the right or to the east. So the value for distance and displacement is just the same. But then the formulas or equations are different. Let's move on to the next problem. An object moves from point A to point C along the rectangle shown in the figure below. Find the distance covered by the object and find the magnitude and direction of the displacement of the object. So here's the figure. So we are to find for distance and displacement. So it was stated in the problem that the objects move from point A, this point here, to point C. So point A to point B and point B to point C until the object reaches point C. So this red line here will be our displacement. This will be change in x. So we'll be solving this one because para siyang shortcut. So itong isosolve natin from point A to point C. So as we can see, this problem para siyang nagpo-form ng right triangle. So in solving for displacement in this one, we will be using another equation. So kanina yung equation is change in x is equal to xf minus xi, or final position minus initial position. Sa case lang na yon. Pero dito, ibang case naman na to. So kaya, ibang equation naman ang ating gagamitin kasi nag-form siya ng right triangle. Tapos, meron tayo ditong angle. Isosolve din natin tong angle na to kasi this will be an indicator for the direction of the motion of the object. So let's find out with the solution on the next slide. Here's the solution for the third problem. As we can see, the distance covered from point A to point C is 8 meters, since we just add the distance from point A to point B and point B to point C. So x is equal to AB plus BC. So this will be the equation we will be using to find for distance. So what is this x? X is the symbol for distance. Yung kanina, yung symbol ng displacement is delta x. Yung symbol naman ng distance is x, which is equal to AB plus BC. Ano itong AB at ano itong BC? So yung AB is the distance from point A to point B, tapos yung BC is the distance from point B to point C. So x is equal to 5 meters plus 3 meters. So sinubstitute na natin yung mga values ng AB at BC. So ito 5 meters plus 3 meters. So we come up with the value for distance, which is equal to 8 meters. Remember also that distance is a scalar quantity, so it doesn't care about the direction of the travel or motion of the object. So it is more focused on the magnitude of the motion. So we will just add the numerical values disregarding the direction of the travel. So we'll just add the numerical values. So we come up with the value for distance, which is 8 meters. Next, the magnitude of the displacement of the object can be computed through this equation. Change in x is equal to square root of AB squared plus BC squared. Since yung problem kanina naka-form tayo ng isang right triangle, we'll be using Pythagorean theorem, which is equal to C squared plus is equal to A squared plus B squared. So, dito galing yung equation na ito. So, yung C, ito yung A, ito yung B. Tapos, yung AB, from point A to point B. Tapos, yung from point B to point C. Tapos, yung solve natin is ang delta x. So, ito yung C, ito yung delta x or yung displacement na hinahanap natin. So next, we will use the Pythagorean theorem since the figure forms a right triangle. Tama. So substituting the values, we have change in x is equal to 5 meters squared plus 3 meters squared. Yung value ng AB is 5 meters. Yung value ng BC is 3 meters. So we will square those two values. So change in x is equal to square root of 25 meters squared plus 9 meters squared. So 5 meters squared is equal to 25 meters squared, and 3 meters squared is equal to 9 meters squared. So change in x or displacement is equal to square root of 34 meters squared. So square root of 34 meters squared, we come up with the value for displacement, which is equal to 6 meters. So we have the value for distance, which is equal to 8 meters, and our value for displacement is equal to 6 meters. We do have the value for displacement, which is equal to 6 meters, but then this 6 meters is only the magnitude. We don't have the direction yet, so we will be solving for the direction. So an angle theta gives the direction of the displacement. We use tangent theta to determine theta, noting that theta is equal to b over a, and using the inverse trigonometric function, we find that theta is equal to inverse tangent, opposite over adjacent. So theta is equal to inverse tangent 3 meters over 5 meters. So we come up with the answer 31 degrees. So the angle is 31 degrees. So kanina sa problem, we have formed a right triangle. So ito yung point A, tapos ito yung point B, tapos ito yung point C. So yung hinahanap nating theta or yung hinahanap nating angle ay ito. Tapos, we have this formula which is opposite over adjacent. Yung opposite kasi is yung katugbang hinina angle. So, ito katugbang hininga angle. So, from point B to point C. So, ang given natin from point B to point C or distance from point B to point C is 3 meters. Tapos, yung adjacent ay ito. Ito yung adjacent. Tapos, ito naman ang hypotenuse. So, ito yung hinahanap natin kanina na displacement. Pero, yung gagamitin natin dito ay yung value ng opposite tapos adjacent or point B to point C, which is the opposite, and point A to point B, which is the adjacent. So, the value for adjacent is 5 meters. So, meron tayong 31 degrees. So, yung angle na ito ay 31 degrees. So, therefore, the magnitude of the displacement is 6 meters, pointing east of south at an angle of 31 degrees. So, east of south yung direction kasi, so you can see here, from point A to point C. So, pa-south siya pero at the east hapon na direction. So, from pointing east of south at an angle of 31 degrees. For you to have a better understanding about distance and displacement, just try this problem. So a person walks 5 meters east, then walks 4 meters north. Determine the distance and displacement of the person walking from east to north. So you may pause this video for you to have time in answering this problem and try to check your answer in the next slide if you will come up with the same answer. The magnitude of the displacement is 6.4 meters, pointing northeast at an angle of 39 degrees. So did you get the same answer? Moving on, we'll be describing and differentiating speed from velocity. What is speed? Speed is a scalar quantity that refers to how fast an object is moving, while velocity is a vector quantity that refers to the rate at which an object changes its position, or the rate of change in speed. So the main difference between these two concepts is that speed is a scalar quantity while velocity is a vector quantity. So meaning speed focuses only on the magnitude of the motion while velocity focuses on both the magnitude and direction of the motion. Speed talks about how fast an object is moving, while velocity talks about the rate at which an object changes its position or the rate of change in speed. So if there is a change in speed, there is a velocity. But the main difference between these two is speed is a scalar quantity while velocity is a vector quantity. So for us to have a better understanding about speed and velocity, let's try some problems or sample problems as we go along with our review. Let's consider this problem for speed. A bus travels 100 kilometers east for 4 hours and then 200 kilometers north for 6 hours. What is the average speed of the bus for the entire trip? So we are asked for the average speed of the bus for the entire trip. And for us to visualize this situation, we have here a figure. So as we can see, the bus travels 100 kilometers east for 4 hours. So from this point here, initial point up to this secondary point, the distance is 100 kilometers and it takes 4 hours to travel for this certain distance. Well, this from this secondary point up to this tertiary point, the distance is 200 kilometers and it takes 6 hours to travel this certain distance. So we are asked for the average speed of the bus. In solving for the average speed, we must remember that the average speed is a scalar quantity. It ignores the direction of the travel, so we can just simply use the formula for speed, which is equal to v, which is the symbol for speed, is equal to the total distance over the total time. So, substituting the values, v or the speed is equal to 100 kilometers plus 200 kilometers since we are finding the total distance, diba? So total distance, in finding for the total distance, we will just simply add the numerical values of the distances. So we will just add 100 kilometers plus 200 kilometers as well as the total time. We'll just add the the numerical values for time. So 4 hours plus 6 hours. So V is equal to, or the speed is equal to 300 kilometers divided by 10 hours. So our speed, or the average speed for the entire trip, is 30 kilometers per hour. Now, let's consider this problem for velocity. A man walks 9 meters east in 5 seconds and then 3 meters in 2 seconds in the same direction. Determine the average velocity of the person. So we are to find for the average velocity of the person. So we have here the figure for us to visualize the situation. So as we can see, from this point, from this initial point up to this secondary point, the distance being traveled is 9 meters and it takes 5 seconds to travel this certain distance. So from this secondary point naman to this tertiary point, the distance is 3 meters and to travel this certain distance, it took him 2 seconds to travel this certain distance. So now we'll be finding for the average velocity, and let's take a look at the solution for this problem. Here's the solution for the problem. So we'll be using this equation to solve for velocity. So as we can observe, the symbol for velocity is the same with speed. But then, as we can observe, velocity has an arrow on top. So this is an indication that velocity is a vector quantity. So velocity is equal to delta x over t, in which delta x is the displacement and t is the time, or the total time. So the formula for velocity is equal to displacement over time, or total time. So the displacement in this case is the measurement from initial position to final position in horizontal line. We will just simply add the numerical values kanina. So 9 meters plus 3 meters is equal to 12 meters. Since we do have now the value for displacement, we can now solve for velocity. So velocity is equal to the value for displacement, which is equal to 12 meters over total time. So we will just simply add 5 seconds plus 2 seconds, and we will now have this 12 meters over, or divided by 7 seconds. So our velocity is 2 meters with the direction of to the east. Why? Because an atom direction kanina is to the east. From the initial position to the final position, the direction is to the east. So our velocity is 2 meters per second to the east. Lastly, we will be tackling the last physical quantity, which is the acceleration. So what is acceleration? Acceleration is a vector quantity that is defined as the rate at which an object changes its velocity. An object is accelerating if it is changing its velocity. So the main point about acceleration acceleration is a vector quantity, so meaning it focuses on both the magnitude and direction of the motion of an object. And also, an object is accelerating if it is changing its velocity. But if an object is moving at constant velocity, meaning the object is not accelerating. So the condition here, when the velocity is changing, then the object is accelerating. So just remember this condition. Since we are talking about acceleration, we must know two terms related to acceleration. What are those terms? The constant and non-constant acceleration. So I have here two tables, and all you have to do is examine these two tables and answer this question. Which do you think shows a constant acceleration, and which do you think shows a non-constant acceleration? Which table shows a constant acceleration and which table shows a non-constant acceleration. So let's find out. So we must remember that accelerating objects are changing their velocity. So for us to say that an object is accelerating, the velocity must be changing. If this velocity is not changing, meaning the object is not accelerating. So based on this table, we can see here that the first column, it has something to do with the time. The second column, it has something to do with the velocity. So in this first table, the velocity is changing by constant amount each second, in which it is referred to as constant acceleration. Therefore, for us to define constant acceleration, velocity must be changing by constant amount each second. So as we can observe here, the time is changing by 1 second. So every second, the velocity is also changing by a constant amount, which is 4 meters per second. So at 1 second, the velocity is 4 meters per second. At 2 seconds, the velocity add up another 4 meters per second. So the new velocity is 8 meters per second. And after 3 seconds, you will add up again 4 meters per second. So the velocity is 12 meters per second. So constant amount each second, the velocity is changing. So that is constant acceleration. Again, constant acceleration means that the velocity is changing by a constant amount. While the second table, the velocity is changing also. So the object is accelerating again. But then it is changing, the amount is changing but not constant. So diri hiya constant, pabalyo-balyo ang iya kuan, ang iya pag-change ng velocity. Let's just say for example, after 1 second, the velocity is 1 meters per second, 1 meter per second. At 2 seconds, the velocity is 4 meters per second. At 3 seconds, nag-add up lang ng 1 meters per second, so naging 5 meters per second. Tapos dito naman, after 4 seconds, nag-add up naman ng 2 meters per second, so naging 7 meters per second. So the amount is changing also, or the velocity is changing by different amounts. So this is referred to as a non-constant acceleration. Constant acceleration meaning the velocity is changing by a constant amount, while a non-constant acceleration, the velocity is changing in different amounts. So that's the difference between constant acceleration and non-constant acceleration. But then, if the velocity naman is constant, meaning the object is not accelerating. The velocity must be changing for us to say that an object is accelerating. So remember those conditions. How do we describe acceleration mathematically? So now we'll be calculating average acceleration. Let's consider this problem. A train brakes from 40 meters per second to a stop over a distance of 100 meters. So we are to solve for the acceleration of the train. So let's find out on the next slide through the solution for us to find for the acceleration of the train. We will now be using the equation for acceleration. So the equation for acceleration is A is equal to Vf minus Vi over T. So this will be the equation to be used in finding for acceleration. A is the symbol for acceleration. This Vf is final velocity and Vi is the initial velocity and T is the time. So acceleration is equal to final velocity minus initial velocity over time. Since we have no value for time, we cannot compute for acceleration using the above equation. So we must find first the value of time. We can use the formula for speed, which is V is equal to distance over time. So we must derive this formula for us to have the equation for time. Deriving the formula by cross multiply. So we come up with this one, V is equal to V over T. So divide both sides by V to cancel out the V in this portion. So our last and final formula or equation that we'll be using to find for time is T is equal to distance over V. So in this case, pwede din tayong gumamit ng triangle method. Ganito. Triangle method, tapos ganito yung setup. So yung V ay dito, tapos yung D dito, tapos yung time dito. So we are finding for time. So ito yung hinahanap natin. So the formula will be distance over V. So dito sa itaas yung D, dito sa ibaba naman yung V. Pero kung hinahanap natin naman ay V, so the formula will be distance over time. Sa itaas yung D, sa ibaba yung T. Pero kung hinahanap naman natin ay distance, they will be multiplied. So distance is equal to velocity multiplied by the time. So since time naman yung hinahanap natin, so the formula will be distance over v, or the velocity, or the speed, I mean. So time is equal to distance over velocity. So substituting the values, time is equal to 100 meters divided by 40 meters per second. So t is equal to 2.5 seconds. So we now have the value for time. So we can solve na for acceleration. Since meron na tayong value for time, we can now solve for acceleration. So acceleration is equal to 0 meters per second minus 40 meters per second divided by 2.5 seconds. So yung 2.5 seconds is the value for time kanina. Masinolve natin. Tapos yung 0 meters per second is the final velocity because the train came into a stop. So we have a value for final velocity which is 0 meters per second minus the initial velocity which is 14 meters per second. So acceleration is equal to negative 14 meters per second divided by 2.5 seconds. So the value for acceleration is negative 16 meters per second. Remember that the negative sign indicates a negative acceleration. It indicates that the object moves from 40 meters per second and come into a stop. So the negative sign here indicates a negative acceleration. So it indicates also the direction of the motion in which the object moves from 40 meters per second and come into a stop. So that negative sign indicates this certain situation. So since we are talking about negative acceleration, we'll be talking this one as well as the positive acceleration on the next slide. Now we'll be talking about the direction of acceleration vector. We will be talking the negative and positive acceleration. So since acceleration is a vector quantity, it has a direction associated with it. The direction of the acceleration vector depends on two things. First, whether the object is speeding up or slowing down. Second, whether the object is moving in the positive or negative direction. So remember, the direction of acceleration vector depends on these things, whether the object is speeding up or whether the object is slowing down, and if the object is moving in the positive or negative direction. So remember these conditions. In determining the direction of the acceleration, we must remember this general principle. If an object is slowing down, then its acceleration is in the opposite direction of its motion. Remember, an object that is slowing down, its acceleration is in the opposite direction of its motion. So we must remember this general principle for us to determine the direction of the acceleration. For us to have a better understanding regarding with the difference between negative acceleration and positive acceleration, let's consider these examples. So we have example A and example B. Table A, table B. So at the first column we have the time, and the second column we have the velocity. So example A tells us that a certain object is moving in the positive direction and is speeding up. Because as we can see in the velocity is changing in every second with a constant amount of 2 meters per second. So from 1 second, the velocity is 2 meters per second. So after 1 second na naman, the velocity changes by a constant amount of 2 meters per second. So naging 4 meters per second na siya. Tapos after 3 seconds, naging 6 meters per second. And after 4 seconds, naging 8 meters per second. So in example A, the object, remember the object is moving in the positive direction and is speeding up. While example B tells us that the object is moving in the negative direction as stated or as indicated by this negative sign. So this negative sign is an indication of the movement or motion of an object in the negative direction. And the object is slowing down until it came into a stop as indicated by this velocity 0 meters per second. So the object came into a stop, meaning the object slows down. Remember example A, the object is moving in the positive direction and speeding up, and example B naman, the object is moving in the negative direction and slowing down. So let's see if this will tell us a positive acceleration or a negative acceleration. In example A, the object is moving in the positive direction, meaning it has a positive velocity and is speeding up. When an object is speeding up, the acceleration is in the same direction as the velocity. Thus, this object has a positive acceleration. In example B naman, the object is moving in the negative direction, meaning it has a negative velocity and is slowing down. According to our general principle, when an object is slowing down, the acceleration is in the opposite direction as the velocity. Thus, this object also has a positive acceleration. So in this case, example A and example B tells us that the acceleration is positive, or we have both a positive acceleration. So in example A, you need to remember that the object that is moving in a positive direction has a positive velocity, and an object that is speeding up, ito ang dapat nating tandaan, that the acceleration is in the same direction as the velocity. So meaning, kung ang object is speeding up, the acceleration is in the same direction as the velocity. So meaning, the velocity of the object that is speeding up, since it is moving in a positive direction, so meaning it has a positive velocity, so the direction of the acceleration must also be positive. So we will have a positive acceleration. While on example B, it says here that the object is moving in the negative direction, so it has a negative velocity and it is slowing down. So according to our general principle kanina, when an object is slowing down, so meaning its acceleration is in the opposite direction as the velocity. Remember the general principle, when an object is slowing down, the acceleration is in the opposite direction as the velocity. So the velocity kanina, since the object is moving in the negative direction, it has a negative velocity. Pero the object is slowing down, so we must follow the general principle. So the acceleration, this one, must be opposite in the direction as the velocity. Since negative velocity ito, so ang ating magiging acceleration dito ay magiging positive acceleration. Since opposite yung direction ng acceleration as the velocity. Since negative naman yung velocity, so yung acceleration naman natin ay magiging positive. Kung kanina yung example A and example B tells us a positive acceleration, tingnan naman natin yung example C and example D. So we have here two tables again, table C and table D. So the first column we have the time, the second column we have the velocity. So example C tells us that an object is moving in the positive direction, but then it is slowing down until it came into a stop, 0 meters per second. So every second, the velocity is changing, or the velocity is decreasing by 2 meters per second. So as we can observe, from 0 seconds, the velocity is 8 meters per second. After 1 second, the velocity became 6 meters per second. So it decreases by 2 meters per second. So while example D, the object is moving in the negative direction as indicated by this negative sign. So it tells us the direction which is negative. So the object is moving in the negative direction and it is speeding up. So after each second, the object is speeding up by 2 meters per second, or the velocity is increasing after each second. Example C, the object is moving in the positive direction, meaning it has a positive velocity, and it is slowing down. According to our principle, when an object is slowing down, the acceleration is in the opposite direction as the velocity. Thus, this object has a negative acceleration. In example D naman, the object is moving in the negative direction, it has a negative velocity, and it is speeding up. When an object is speeding up, the acceleration is in the same direction as the velocity. Thus, this object also has a negative acceleration. So as we can observe in example C, we have here a certain situation in which the object is moving in the positive direction and it has a positive velocity, but it is slowing down. So in order for us to determine the acceleration, we must consider the general principle in which when an object is slowing down, so meaning the acceleration must be in the opposite direction as the velocity. Since the velocity is positive, so the acceleration must be negative, since the acceleration is in the opposite direction as the velocity, because the object is slowing down. So that's it. How about example D? Example D, it states here that the object is moving in the negative direction. So it has a negative velocity, but it is speeding up. So when an object is speeding up, the acceleration is in the same direction as the velocity. Remember, when an object is speeding up, the acceleration is in the same direction naman as the velocity. So meaning, since the velocity here is negative, so we must have a negative acceleration because it will be the same in the same direction as the velocity. Okay, that ends our review, and I hope you learned something today, and I am also hoping that you will take note all the important things, just like the different physical quantities such as speed, velocity, distance, displacement, and acceleration, also their differences, as well as the difference between scalars and vectors, and how you will classify the different physical quantities as scalars or vectors, and most importantly, try to remember or familiarize all the equations used in solving problems in relation to these physical quantities. So that's all. Thank you and God bless, and good luck for your pre-board examination.